Alright, today you're going to get a video where I'm going to go through and talk about your homework. Now I'm going to specifically focus only on the actual homework assignments and not the review assignments. There are videos for those review assignments. Please feel free to do those as you come to them. So what I'm going to do is I'll walk you through the steps and processes for completing your homework, and hopefully that will teach you enough to understand what you're meant to do and lead you on to your next levels. So today what we're going to do is we're going to begin 2.3, which is a lesson about functions. Now functions, you don't need a really in detailed explanation of what functions are. You just need to be able to recognize what a function is, and then we'll talk a little bit later about function notation and how to use functions. So today we're going to begin in 2.3 with what I hope is a very exciting exercise for you because it's quite easy. But it does require that you understand a few terms. And that's one of the problems that math students have, is they concentrate on doing the math, but they forget that they need to understand the words, the terms. Mathematics has its own language, and if you don't learn that language, then you're not really learning mathematics. Okay? And the first one that we come across in 2.3 is the word domain. Now, the domain of a function is very easy. The domain of a function simply means every possible x value. So in other words, any x that would satisfy the function that you're working with. Now remember that we worked with equations. We said that satisfy meant that if a number satisfied it, it made it true. So this is all of the x's that make the function true. Now before we go on and talk about domain and how to determine domain, I want to remind you a little bit about something called an ordered pair. Now you ran across this in graphing before. Hopefully none of the material that you see, or most of it, will not be new to you. If you're working at this level, you've had some algebra in your past, but I'm going to go from the point of view that you've forgotten most of it. So we're going to take it at a very basic level, which is going to drive some of you crazy, but others you're going to think, yay, I really needed that extra help. Remember that an ordered pair always comes in the form of x, comma, y. In order to know that it's an ordered pair, they're always enclosed in parentheses, and they're always separated by a comma. That's how you can tell that something is indeed an ordered pair. And a set of ordered pairs can define all of the solutions with the numbers that satisfy a function. So we're going to be looking at some ordered pairs quite a lot in this section, so it's very important that you understand that it's always x, comma, y. These could be other letters. This is just traditional. It could be a, comma, b. But what's important is they always come in alphabetical order. So x comes before y in the alphabet, so therefore x comes before y in your ordered pair. Okay? So make sure that you're really paying close attention to the order of the ordered pair. And here, because we're talking about domain, we're talking about the x values. So say, for example, in problem number 1 from your homework, we have a set of ordered pairs. That's what this funny little braces mean. It means that you have a set. And so you have the set 8, comma 2, comma 6, comma 9, comma 13, comma 10. Notice that all of those are in parentheses, and it's two numbers separated by a comma. That's the very definition of an ordered pair. Now, because we have the brackets, the braces, I'm sorry, around each side. That means that this is a set of specific values for this function, okay? And all we're asked to do is find the domain. Well, remember that the domain is simply the x values of all of those. And remember that x is always the first number, so it's simply 8, 6, and 13. So the set of all possible numbers for the domain for this particular function are these numbers. Now, when you're doing your examples, your numbers will come up different, maybe different. Each example comes up with a different set of numbers, but all you have to do for the domain is find all of the possible x values. Now later we'll expand that, and you'll learn other ways to find the domain. For example, you're not going to be able to always be able to have the actual numbers in front of you. You're going to have to be able to look at a function, at an equation, to be able to find those numbers. But for now, they simply want you to find them by looking at the x values. Okay? All right. Now, let's look at another bit of business that you're going to be working with lots of functions, and that is what you're going to be looking at is finding function values. You may have seen in the review section that they spend a lot of time having you replace a letter with a number and then doing the math for that. And that's exactly what you're going to be doing here. So let's look at the steps. First, what you want to do is simply replace the letter with the number given. Now they're going to tell you exactly what number that you're going to use. You have to remember to use exactly the number that they're giving you. I can't tell you how many times I've seen students do beautiful work and have dropped a sign or lose an exponent or something. So be very careful when you're writing these. And my advice is that every time you write them, you use parentheses. And I'll demonstrate that as we go through the example. So because you need to make sure that the operations stay true, and if it means to multiply, then the parentheses means to multiply. So you have to continue to do that. Second step is simply to simplify. Now simplify is a math word that just is a big broad term. It simply means do the math. And if you'll remember, in the first chapter, we looked at the order of operations. And so you have to pay close attention to the order of operations anytime you're doing any mathematics. If you don't follow the order of operations, then you're not going to get the correct answer. Right? And once you've done that, then you have your answer. Okay? So let's look at an example really quickly. And again, I'm pulling these straight from your homework. So, number 5 in your homework, for example, says for the function f of x, and that's how you know that something is a function. That's called functional notation. A function, and the variable in it is x, is all that means. We have negative 2x plus 4. And they want you to find f of negative 5. Now, notice I said f of negative 5. That's how that's read. F of negative 5. That simply means everywhere there's an x, right? Because it said f of x here. Everywhere there's an x, we're going to replace it with negative 5. And we're never going to replace a number with a letter, a letter with a number without putting it into parentheses. Now remember, your calculator is very helpful here because your calculator can do these calculations for you if you'll just enter it correctly. You have to be very, very, very careful about entering these parentheses in just exactly the right spot. So for this particular function, we're finding f of -5. So that means, do you see here, all I did was replace that x with -5. And that's what we're going to do in the actual mathematics. So -2, there's our x. So we're going to replace it with a -5. But remember, you never replace a letter with a number without putting it in parentheses, because we couldn't just say -2 minus 5, because that means combining, whereas 2x literally means multiplication. So you have to keep it true, especially if you're entering these into your calculator. If you don't get that parentheses in there, then your calculator is going to use the wrong operation. And then finally, +4. Now, using the order of operations, we have to get rid of these parentheses first. So here's where the parentheses begins. I'm not going to write down the f of -5 part. I'm just going to put the equals. And we know that if we don't write something on this side, it just stays the same. I'll write it in the answer, however. So here we'll take -2 times -5. And again, if you know your sign rules, I love you for that. If you don't know your sign rules, I love you for using your calculator. Okay? So put in -2, parentheses, -5, close parentheses, and then hit enter, and it should give you +10. Negative times a negative is positive, 2 times 5 is 10. Now, the +4 was not part of the parentheses, so I'm just going to bring it down. Now, most of you are going to be sophisticated enough not to have to write down every possible step. But since I'm demonstrating the behavior here, I'll write down every possible step. I'm going to assume that you know nothing. So that means that if you do know something, you'll feel that much more confident. Okay? Now the next thing I have to do is simply do the rest of the mathematics, which simply means add 10 and 4. So then again, put that in your calculator. No one is going to judge you for using that machine. No one judges you for using your car instead of walking, right? So use the machines that you have at your disposal to do the math. 10 plus 4, of course, is 14. So the final answer, f of -5, in other words, if I replace x with -5 in this function, we get 14. Now, Course Compass is only going to ask you to enter that number in the spot. They'll already have the f of -5 in there for you. Okay? I'm going to be showing you lots of ways that you can use Course Compass to make your life easier as we go through the course. Okay? Let's see what's next. Excuse me. All right, there's another function. Finding the function value, all you have to do is replace the letter with the number and making sure that you use the symbols correctly. Now this one, don't let it freak you out because it has some other symbols in it. It's f of x equals the square root of x, and they want you to find the function value when x is, find f of 144. So that simply means place the x with 144. So f of 144 equals the square root of 144. Now notice I didn't use a parentheses this time, and I didn't really have to, because if you'll notice the x is all completely by itself without anything multiplied or anything else. So if it's all by itself, that's the one and only time when a parentheses is not absolutely necessary. Now if you wanted to put it in parentheses, it would work out exactly the same way, and you can enter it in your calculator. So again, you have different calculators, so I'm going to tell you, I can't tell you how to put this into your calculator. You learn your calculator. For most TI calculators, you would hit the square root key and then 144. But for some other calculators, it's you hit the 144 first and then the square root key. So you make sure that you understand how your calculator works. You'll be able to use your calculator on the tests. It is your friend. So if you hit the square root of 144, the number times itself that makes 144 is 12. and that's what your calculator will give you. So your completed answer, f of 144, equals 12. And again, the 12 is the only thing that you'll need to enter in Course Compass, or I keep calling it Course Compass, I'm sorry because I'm old. This used to be called Course Compass, now it's called My Math Lab or My Lab in Mastering. I'm afraid that you're just going to have to get used to me saying Course Compass, but I'll give it a shot trying to use the terminology that you're used to. Okay? All right. So that was finding function values. Now let's look at the next thing they ask us to do in this particular section, and that is to determine, is a relation a function? Now, please don't make fun of my handwriting. I can write better than this, but you try writing on an iPad and see how it works for you. All right? You might also hear some noises going on as I'm sitting in my kitchen doing this. So, is a relation a function? Not every relation is a function, but it's easy to tell that if one is a function by looking at the domain. Okay? So we tell if a relation is a function by looking at the domain. Okay? And remember that the domain simply means the x values. Now there are other ways to find out if something is a function, but that depends on the information that you're given. We're going to be given a bunch of ordered pairs, which means we're going to be looking at the x values. Okay? And the way you know it's a function is no x value can repeat. All right? So let's say we have the ordered pair 8, 3, 4, 2. I'm just making these up, by the way. And -3, -6. All right? So if you look at your x values, or the domain is 8. From there you get a 4, and from there you get a -3. Do any of those repeat? No. Since there is no repetition, so no repeat, it is a function. Okay? And that's all we have to worry about right now. Now, let me show you another one. What if I were given 4, 2, 3, 6, 4, 2? Now the domain of this one is 4, 3, 4. So it looks as if this is not a function because one of my numbers repeats. But it really isn't repeating. What's happening is we've simply written down the same exact ordered pair twice. And if you do that, we don't care about this one. Right? You wouldn't, if you were listing your children's names, for example, you wouldn't say one of them twice, right? And that's what's happened here. They've given us some information that we really don't need. We didn't need to know that point because we already knew that point existed. Okay? So yes, it is a function. Now, having said that, watch this one. Okay? Okay, our domain, again, are simply the x values. We have 4, we have 3, and we have 4. Now this is suspicious to me because the 4 occurs twice. So what I'm going to do is I'm going to look up here and see just the ones that have 4 as my x value and ask myself, are those the same point? But this one is 4, 2, and this one is 4, 5. So that means they're different points, which means that two x values repeat without being the same point, right? Remember up here, those were the same point, so it didn't matter. point is another word for ordered pair. So here, the answer would be no, this is not a function. So do you see the difference there? If they repeat, but it's the same exact point, we don't really care. We were just given too much information. But if they repeat and it's not the same point, then no, it's not a function. Okay, the relation is not a function. Okay, so just more of that. Is it a function? I'm simply clicking through your homework. Now they may give you some information depicted in a different way. You can also have your x and y values given to you in a chart form. This is simply a way of organizing the information a little bit differently. So in the example, they give you 5, and then 6 and 9. And over here, they give you -4, -4, -4. And they want to know, is it a function? So what I'm going to do is I want the domain. And remember that domain only means the x values. Sorry, I'm used to being in a classroom, so I'm going to be asking you questions sometimes. And I know you can't answer me, but bear with me. Teaching online is something I've been doing, but I usually use recordings of my classrooms. So here we go. My x values are 5, 6, and 9. Do any of those repeat? No. So since there's no repetition, then yes, it is a function. Now, notice here that all of the y values repeat, but I don't care. Remember, the domain is only the x values, so those are the only values that you care about when you're trying to determine, is something a function? Okay? All right, so let's move on. Now we know that the word domain always refers to the x values. Well, the y values also have a name, and the name for the y values is called the range. And again, finding the domain and range is very simple if they give you a list of points, and then they're also going to ask you, is the relation a function? So let's just go through one where you can see all the parts of the problem. So we have 4, 7, then we have 20, -6, then they have 42, 7, let's see, 4, 9, and then finally 53, 9. Okay? Now, what we're going to do first is find the domain. And remember that the domain simply means every x value. So 4, 20, 42, 4, separate them by commas, and 53. So we have every one of our x values represented there. Okay? They're already going to put in the braces for you because these things are sets of numbers, so they need to be included in braces. Okay? The next thing we want to find is the range, and the range simply means the y values. So let's find our y values. Remember, y is the second number from the point. So 7, -6, don't forget those signs, 7, 9, and here's another 9. Now when you notice from this list that some of the numbers in the range repeat, and we don't need that. Okay? So anytime a number repeats, we're only going to write it down once. So the true range for this is 7, -6, and 9. Okay? We don't need the repeats when we're writing down the range. Okay? We already know that one of the values is 7, so we don't need it again. Okay? Now, we need to know, is this relation a function? And remember, function doesn't have anything to do with range. Function is found by domain. Do any of the numbers in our domain repeat? Yes, they do. The 4s repeat, right? So let's go up to the points here. This one is 4, 7, and this one is 4, 9. So, are those in the exact same point? No, because this one is 4, 7, and that one is 4, 9. So in this case, no, this relation is not a function. Now it still has a domain, it still has a range, right? But it's not a function. So be careful though with domain. We care that they repeat unless they're the same point. With range, we don't want any repetition at all. We don't care. Okay? And that's the thing that confuses students with mathematics, is that you have to be very specific about what it is you're looking at in order to be able to determine the answer. Okay? And we too often don't focus on the definitions and the ideas. All we want to do is punch numbers into our calculator and get an answer. Okay? So be very careful to focus on these words, and that's what those notes from the PowerPoints and doing your notes on Canvas helps you with. Okay. Another way they're going to determine if a relation is a function is by giving you two little circles and then drawing some arrows to see if a relation is a function. And as long as none of the arrows goes from one x to another, then you're in good shape. Because really what you're doing is you're creating ordered pairs. Okay? So they'll give you two circles. Here they give you 10, they give you 3, and they give you 24. Here they give you 20, they give you 25. Okay? Now, so remember that these really represent ordered pairs. Now they're going to give you a series of arrows. This one, they give you that 10 goes to 20. They say that 3 goes to 25, and that 24 goes to 20. And you might be tempted to say that since both of these lead to 20, then this is not a function. But remember, these are just ordered pairs, so let's just write them as ordered pairs so you can really see that this is indeed a function. 10 goes to 20, so that's the ordered pair 10, 20. Okay, 3 goes to 25, so that's the ordered pair 3, 25. And then 24 goes to 20, so that's the ordered pair 24, 20. Now, in order to determine if it's a function, all we're interested in is the domain, which are the x values. So we have 10, 3, 24. Do any of those repeat? No. So, yes, this is indeed a function. Okay? Now, if I wanted the domain, I'm just going to abbreviate that. The domain, we already wrote there. Never mind, I'm not even going to abbreviate it. I already wrote it down. Now, the other part of information they want from this is the range. Now, in the range, those are the y values. Well, they're already separated out there for you. All you have is 20 and 25. Now, when we wrote it out as ordered pairs, these two 20s repeated. But again, remember, with the range, we don't want repetition. Okay. Here's another one. The next one they give you in number 23, they give you the same information, but they just give you the information in a chart where you have your x's and your y's. So just make sure your x's don't repeat. Usually it's easiest to find the domain first and then answer the question, is it a function? Okay, let's see. All right. Now they give you some information in a chart, but this time they give it to you a little bit differently. This time they say that there are years, but they tell you that those are your X values. And then they tell you the number of visits, but they also tell you that those represent your Y values. So you can see that a chart doesn't really matter. It's still, and I'm not going to write down this whole problem, 0.1, 60.4. So that's your X value, that's your Y value. And you see that none of them repeat, so therefore it is a function, right? So they may give you specific items, because that's where these numbers come from. You know, having an X and a Y, just some arbitrary numbers, doesn't really do anything for you. These numbers actually come from real life situations. So having an X and having a Y means specific things. Okay? So they may give it to you in words instead of saying X and Y. Let's see what else they do to you. Okay. Now, the next thing that they do is they give you a graph. A graph is simply a picture of the information, right? So let's say, for example, we have a graph. They give you a little square, and it's always divided by two axes. Okay? The horizontal one is your x-axis. Your vertical one is the y-axis, the one that goes straight up and down. And then it gives you a little grid, right? And that grid will allow you to count your x and y values. But for right now, we're worried more about the introduction of the pieces we were looking for: the domain, the range, and is it a function? Okay? And when you have a picture, finding the domain and range is a little bit different, because you can't list all of the ordered pairs that represent a straight line. There are an infinite number of them. Okay? So let's see if I can get some graph paper going on over here. There we go. Okay, so here we are with some graph paper, and that will help us out a little bit. Alright, now you see that my graph is a little wonky, so we'll straighten out these lines a little bit. And it's been a while since I've done this, so bear with me. Alright, so okay. So we're given a graph, and then we're just given a line across the graph. Doesn't matter where the line is, actually, we can just fudge this. Okay? Now, you see that the line goes all the way from one edge to the other, right? Well, when you're reading domain and range and finding out if something is a function, you're always going to read the domain from right to left. So, in other words, when you're reading the domain and you see that the line goes all the way, from one edge to the other, that means that it goes on infinitely. Remember that if something goes on forever, we call that infinite, right? And you'll remember, hopefully, that as you go this way, your x's are negative. If you go this way, your x's are positive. If you go up, your y's are positive. And if you go down, your y's are negative. So if we're starting over here, all the way over to the left, then that means my x is a negative number. Now, because it's on the line there, on the edge of the box, and they even put a little arrow there to indicate, right, that it keeps going forever. Nice of them. As long as you see that arrow, that means it goes on forever. Well, that means it goes and we're reading it from left to right, yeah, so across like this, just like you're reading numbers on a page or letters on a page, words. So we start here, and it's going that way. Looks like it's going up, but it's also going left. It's going left forever. So our domain is negative infinity. And infinity is simply that little 8-looking thing laying on its side. Make sure you put negative infinity, and it's also going to be given in the form of an ordered pair anytime you're building one of these with a line. So then, and it keeps on going. This arrow means that it also goes forever to the right. So the domain is from negative infinity to positive infinity. That's really common. You're going to see that a lot. Now for the range, okay, let's do the range on this side so I can keep it a little more organized. If the domain is measured going from right to left, well, do you see I make mistakes just like y'all are going to do? Let's turn that to left to right so that it can be correct. I just did that to see if you were paying attention. Actually, no, you'll understand that I'm just as human as anybody else. So from the left to right, as you read, just like you read, can't tell my left from my right apparently, then when you're talking about the finding the range, what you're going to be doing is you're going to start from the bottom up. Now I know I'm right on that one, so you don't have to wait for me to change that in just a minute. So if you look, this one goes all the way down, and we know that because this arrow says it goes down forever. It's not going straight down, but it's going down, right? So that means it's going down forever. So down forever is negative infinity. And if you look at this arrow, it's going up, and it's going up forever. So that means it goes up to infinity. Okay? Now, so that's the domain and range. It's just how far it goes over versus how far it goes up and down. Okay? Now we still need to determine, is this thing a function? So let me give you how to determine if something is a function when you have the graph. If it's a function, you'll use what's called the vertical line test, which simply means you're going to draw vertical lines. And remember, vertical means up and down, right? Okay? And the way you know that the test works is it's only going to cross at one point, cross once. So if you look here, these little lines on the graph are vertical lines, aren't they? So notice that I'm just drawing along those vertical lines, and no matter how many of them I draw, my vertical lines are only hitting the line that they draw, and it's blue on the when you're looking at your graph, so it's really easy to see. It only crosses it at one point ever. And if that's the case, then yes, it is a function. Now if it hits more than once, then it's not a function, and I'm sure they're going to give us some examples of that. Yep, the very next one does. So let's look at the very next graph. So again, we have our graph, we have our y-axis, we have our x-axis, okay, and we have a graph that looks like this. Now notice it doesn't look as if it's opening very much, but it really is. It continues, these two sections right here continue to get wider and wider and wider all the time. So it really is spreading out forever. Okay? So the first thing we're going to do is we're going to determine our domain. All right? Now, oops, we're on the wrong thing here. Let me redraw this line a little bit more carefully. Okay? Now our domain is all of our x values. And you'll notice that it does indeed have arrows on both ends, right? But remember, the domain is read from left to right. So you're going that way. And if you're in this section of the graph over here, I'll just show you what I mean. If you're over here somewhere, there's this graph doesn't even exist in those sections, right? So you're not even going anywhere there. Okay, take that off. The graph doesn't even start until you get right there when you're coming from the left. Okay? So we're walking to the left and we hit the graph first right there. Well, that value, okay, means that you haven't left the y-axis. Remember, this is the y-axis. Okay, and this is your x-axis. So that means we haven't gone anywhere in the x direction. We're still right there in the middle. Okay? Okay, so that means that since it doesn't exist in any of these areas, I don't need to include any of that area in my domain. And remember, this side of the y-axis is where my x's are negative. Okay, so what's happening is it starts the graph, the line, the blue line and the black in my case, is starting right on that line with the y-axis. And if you'll recall, that means that's the point where x is equal to 0. So the domain here starts at 0. Okay? Now, you will notice, however, that it has arrows going forever to the right. Well, forever to the right means that I'm going to get, I'm going to get an endpoint of the domain as positive infinity. Okay? Now we'll do the range. Now remember, the range starts at the bottom, goes to the top. Now these arrows indicate it forever, right? So that means, and it doesn't look like it, but this thing again is spreading out forever. Well, spreading out forever down and spreading out forever up indicates that it's going to, at some point, just go forever down, and then it's going to continue forever up. Okay? Now the last thing that we need to do is we need to use our vertical line test, remember, lines straight up and down through the graph, to determine, is this indeed a function? So let's just go ahead with some red lines. If you draw a red line right there, you'll see that it crossed the graph there and there. Now I could do more, but I don't have to. I don't care. Because if any one vertical line crosses your graph twice, then automatically you know that this is not a function. So no, it's not a function. Okay? We can still do domain and range, but then we can use the vertical line test to determine if it's a function. Let's see what else they do to us here. Give us another graph. Doesn't matter how curvy or up or down it goes. Just follow those. There's another where you're just finding the function value, so just plug in the number for x. I don't know why they put it here and set it back where we did them before. There's another one. Be careful with those exponents. There's one with a fraction. Don't let the fractions throw you, because remember, you can let your calculator do the fraction for you. As long as you understand how your calculator works. Finding f of 1/2, simply -2 parentheses 1/2 plus 3. So just enter that as -2 parentheses and 1 over 2 is this, as you can look at your fractions. There's usually an A, B, C key for most calculators. That's how to enter a fraction. So just put the 1/2 in there and then plus the 3. Or you can remember, negative times a positive is negative, and half of 2 is 1. So you use your own level of mathematics ability. But if you need that fraction, those fractions mess you up, then learn the fraction keys for your calculator. I guarantee it's a lot easier to learn those fraction keys on your calculator than it is to go back and relearn all the rules for fractions. Okay? Let's see. Another one, they want you to find a number, so they just have you plug it in. Another one where you're simplifying. Okay. Alright, this one is slightly different and a little odd, but that's okay. If f of x equals negative 5x plus 6, what they want you to do is find f of negative x. So if you look and notice, the only thing that they've done is they've changed the sign of the x. So what you're going to do is you're going to replace this x with negative x. So negative 5 times negative x plus 6. So you just see you haven't really changed anything. Most students would think, oh, that means I need to change all the signs, but really it means replace the x with the thing given, which in this case is negative x. Positive times a negative, negative times a negative is positive. 5 times x is 5x. And then the 6 doesn't have an x, so it's not included. And these two are not like terms because that's an x term and that's a number term. So your completed answer is simply 5x plus 6. So don't let yourself think, oh, I need to change every sign. Remember, the function value only affects the things that have x's in them. Okay? You can also have more values inside. So say, for example, we have the function, we have the function f of x equals negative 3x plus 4. And they want you to find f of x plus 2. So that means that everywhere there's an x, you're going to replace it with x plus 2. And then you'll simplify. So negative 3, in place of this x, I'm going to put x plus 2 plus 4. Now remember, we always have to deal with our parentheses first, and we know there's going to be parentheses because we put them in. So this is the distributive property. So I take negative 3 times my x, which is negative 3x. And then I take negative 3 times positive 2, which gives me negative 6. Now your calculator can't do the x parts unless you have a graphing calculator that can, but it can still do the signs. And then the 4 is not part of the parentheses, so just bring it down. Now this one we're not quite done with because these are both numbers, and we can always combine numbers. So that's negative 3x, negative 6 plus 4 is negative 2. And again, just plug that into your calculator if you don't know the sign rules. This is not a course about fixing your math mistakes for the rest of your life. One of the things that I want you to learn is how to be able to use the tools that you have at your disposal. Let's see. Very similar one, the next one. Okay. Now, what they're going to do is they're going to give you something that's going to look horrible, but it's not. Let f equals 2, 3, 6, 2, and negative 2, 5. Now these are all ordered pairs, right? They want you to find f of 2. Now remember that whatever number you have inside here really is your x value. Okay? So there's really no math to do here. Look up here at your ordered pairs, and here are your x values. Which one of those is a positive 2? It's right here, yeah? And what y value do you get from that? They already give it to you. It's a 3. So f of 2 equals 3. So in other words, what happens when you replace x with a number is that you get y. Literally, f of x equals y. That's another way of saying it. This is what you would get if you replaced your f of x with a number. Okay? So you're just going to read that straight from the ordered pair. Now they give you some that are in the circles with the arrows leading to it. So like say that's 1. If you wanted to find f of 1, then that led to 3. Then f of 1 is 3. Don't make it complicated. Okay? Right? Then they want you to use the graph to be able to find a function. Okay? Now, when you're reading a graph, remember you have to just be very careful about knowing that your x values and your y values, and they'll have it drawn much better than I can. So they're giving you a graph. Let's say that it goes across like this. All right? And say they want you to find f of 0. Well, that's where x equals 0. Well, x equals 0 right there, because you didn't go right any or left any. Notice, so what we want to do then is remember that the value of a function, f of x, is equal to our y value. Well, if you're looking at this particular graph, and here's our line, let's make our line, highlight our line, so you can tell the difference between the axes. If that's our line doesn't go up or down from that point in the middle either. That's a point called the origin, and that means our y value is also 0. Okay. Now it's not always 0. They give you another graph. So our y-axis, our x-axis. You're going to hate this graph. It's crazy looking. So it's 1, 2, starts there. 1, 2, 3, 4, 5, 6. I'm trying to be very accurate for you, and it's going to take me a little more time, so have patience. Okay, so here's our graph. It goes, oops. It goes up, goes down, and then it goes back up again. Okay, so there's our line. And they want you to find f of several different numbers this time. So first one is f of negative 3. Well, f of negative 3 means that if you start in the middle and go to the left 3, there's where x equals negative 3. And notice at that point, you haven't gone up or down any, which means you've gone up or down 0. Let's look at another one. They want you to find f of 4. So go over here to 4, that's a positive 4. So starting here, so it's 1, 2, 3, 4. So positive 4 in the x direction is right there. So what we need to do is we need to go up until we cross that line, which is right there. Okay? And how many lines did I have to go up to get there? So there's 1 and there's 2. So f of 4 means that to get to the line you had to go to 2. You had to go up 2. So that's a positive 2. If it was down, then that means you'd be going in the negative direction. Okay? So just count the lines until you get to the right, until you hit the right point. Okay? Same thing, reading the graph. And then there's one more where we're talking about increasing, decreasing, and constant. Okay? So let's talk about that. Increasing means that the line is going up, right? Always from left to right. Decreasing means that the line is going down from left to right. Okay? And constant means that the line is flat. Okay? Now, don't let these drawings, these mess with you, because it can look a little different when you're looking at a graph. So let's look at a graph here. Say we have the graph. It's going down, then up, and then flat. Okay? Now, I'm just going to give you some arbitrary points. So, but we're going to put the arrows on, which means they go on forever. So as we're walking along, right? Walking along from left to right. That's how we read it. The first part of the line we hit is right here. And from there to there, the line is going down, right? Which means that it's decreasing. Now they're going to want to know the interval. In other words, from where? Well, if it's going, this arrow is pointing left forever, right? And we already determined that left forever means negative infinity. And then it stops here. Well, let's say that this point is where x equals negative 3. So it stops at negative 3. Okay? Now, from this point, however, from there to there, it's not going down, it's going up. So I need to know from here to there what it's doing. Well, I already know that this little point down here is negative 3, and you can read that from the graph, and they also give you the points. Okay? And what I need to know is, where does it stop going up? And if you count this over, if that's negative 3, that's negative 2, negative 1, that's 0, so that's 1. Let's pretend that that's hitting right there, okay? So it goes up until you get to 1. Okay? Then the next part of the graph changes direction again, but this time it's flat, which means it's constant. Okay? Oops, let me fix that. That means increasing from there. And now we need to know where it's constant. And again, the line's continuous, so that means it doesn't ever stop. So it stopped increasing at 1, which means that's where it becomes constant. But this arrow means that it continues to be constant forever to the right, which is infinity. Okay. All right. Now, you can have curves. It doesn't have to be straight lines. You look at this, right? Look at what's happening. This is increasing, decreasing, increasing, right? And then, so what you have to do is find these little points where it turns, and that tells you where it changes direction. Okay? And watch out for the little arrows. That tells you infinity, right? Okay. Well, I hope this helped. That's an hour out of your life that you'll never get back if it didn't help you. Hopefully you see what kind of thing I'm going to be doing. I'm going to be just working through a different type of every one of your problems here and giving my take on how to make it as easy as possible. Again, focus on the terminology. Don't just do the math. It's really going to make a lot of difference if you'll do that. Okay? Take good notes. You should write down everything that I've written down, right? And you should take very careful notes as you're working through a problem as well. you're still more than welcome to use the question help to help me solve this. I don't like as well as I like view an example. View an example makes you actually do some of the work. There are also videos of other instructors. You might like them better. I don't care. You're not going to hurt my feelings. I get paid anyway. You can also look at the textbook examples, which are okay. And there's an Ask My Instructor button, which will only send me which problem you're having trouble with. It won't tell me what trouble you're having, so you need to send me a picture of your work so I can see where your issue is. Okay? Feel free also to make me videos and send them to me. I'm happy to help in any way I can. Thanks. Bye.